टॉपिक देखते हैं आगे का नेक्स्ट, विच इज अल्फा डिके. सो द नेक्स्ट टॉपिक इज द अल्फा डिके. And let's calculate alpha disintegration energy. Suppose there is a nuclei ZXA and it convert into some another nuclei with atomic number Z minus 2 and the mass number A minus 4 with the helium nucleus 2He4. The Q value of the decay process is known as the alpha disintegration energy, which is the total energy released in this disintegration process. So what is the Q energy of this alpha particle? It is nothing but mass of X minus mass of Y minus mass of alpha particle into C square. Convert mass into the energy from Einstein mc square relation. Okay, so C is the speed of light in vacuum and m are the masses of the particles X, Y and alpha particle. For heavy nuclei, Q alpha is always positive. So the decay can occur spontaneously as it does. So according to the laws of conservation of momentum energy, it is clearly visible that initially momentum was 0 and after that alpha particle one goes one side and Y particle goes to another side. So it is m alpha v alpha minus my vy. Why? Because there is X particle and it is disintegrate to the alpha and into the Y. Okay, so from the conservation of momentum we write down it in this way, and Q alpha is kinetic energy of the alpha particle. So it convert into the kinetic energy of the alpha particle and the kinetic energy of the Y particle. Okay, so now Q alpha is equal to this half m alpha v alpha square 1 plus m alpha upon my. Okay, so I just take common m alpha and so it becomes this. I think I made a mistake. Instead of writing, let me check m alpha v alpha square. So okay, let's check. Yes, so we can do from this equation m alpha v alpha is equal to m by vy. So instead of this m by vy, just put the value of m alpha v alpha and you will get this relation. Okay, it's very easy. Okay, just put m instead of m by vy, put m alpha v alpha. Okay, or instead of vy, just put m alpha v alpha upon my and whole square. Then it convert into this equation. Okay, what is this? This is the kinetic energy of the alpha particle. So T alpha 1 plus m alpha my. ठीक है ना? तो इस इक्वेशन की हेल्प से ये इक्वेशन इसमें कन्वर्ट हो गई. Okay, so just use pen and paper and solve this. Okay, so it's very easy. So Q alpha is this. Q alpha is T alpha 1 plus m alpha my. So kinetic energy of the ejected alpha particle is this. T alpha is in terms of the Q alpha, it is this. And now you can write down the Q alpha. See, because Q alpha is T alpha 1 plus m alpha my, you can write down my plus m alpha upon my, and you know that the mass number of y is just less than the mass of the x. My plus m alpha is x. So mass of x is A, mass number, and mass of y is A minus 4. So it is this. So that's why Q alpha is this, or the kinetic energy of the alpha particle is this 1 minus 4 upon A. So it is the formula of the kinetic energy of the alpha particle. Okay, so if A is a 200, then you can calculate very easily that T alpha is approximately equal to roughly equal to Q alpha. Okay, so this is the alpha disintegration energy. Okay, and we can solve few numericals on the basis of this alpha disintegration energy. It is very useful for various kind of examination. So let's solve. Let's solve one problem from the gate examination. The problem is this. A nucleus having mass number 240 and it decays by a emission to the ground. State of its daughter nuclei. The Q value of the process is 5.26 mega electron volt. The energy in the mega electron volt of alpha particle is what? Of alpha particle is what? So it is from the gate examination. So options are 5.26, 5.17. So I really advise you just try to solve yourself. Think little bit about the problem and solve yourself. It's very easy, okay, because they are asking the energy of alpha particle. You know the formula of the energy. So what is the formula? Formula is this. And Q is given to you 5.26 mega electron volt. And A is given to you. So it's not very difficult task to calculating these things, and the final answer from the calculator, with the help of calculator, it is this. It means option B is correct. Okay. So in this way you can solve the numericals. Okay. There is another very good problem from the gate examination. You can check in the previous year of the gate questions paper. These are kind of the problems asking. They are asking. The disintegration energy is defined to be the difference in the rest energy between initial and final state. Okay, consider the following process. This. This is a process, and the emitted alpha particle has a kinetic energy 5.17 mega electron volt. The value of the disintegration energy is number 1 5.26 mega electron volt. Number B 5.17 mega electron volt. Number C, 5.08 mega electron volt. Number D, 2.59 mega electron volt. So the solution is very simple. We know that T alpha is Q alpha and 1 minus 4 upon A. And they are, instead of asking T, they are asking Q alpha, disintegration energy. So it is T alpha 1 minus 4 upon A. So T alpha is 5.17, which is given, and you can put the value of A, which is 240. Just calculate it and find out the answer, which is nearly equal to the 5.26 mega electron volt. Means option A is correct. So in this way you can solve the numericals related to the disintegration energy of the alpha particle. Okay, so it's a very useful technique. It's very easy. Just need to memorize the formula. Okay, so if you have any kind of doubt or any query, just put comment, okay, in the video. आपको कोई भी doubt है, query है, and I will try to solve your doubt. Okay.